Hey everybody, welcome back to our second video for Notes 3.3, where we're going to continue the conversation of confidence intervals. Now, remember what we're basically doing in this confidence interval is setting up a point estimate, the sample in the middle, and accounting for some plus or minus, some error on either side. And everything we are doing is based off of a certain level of confidence. Now, that certain level of confidence, we normally see it with the letter C, is actually connected back to what we've been doing in 3.1 and 3.2. To say that I have a confidence level of 95% or 0.95, what I'm really doing is setting an area between two values to be 0.95. And just like we did in the last lesson, that means I can have the probability of two z-scores, z1, z2, right? The two z-scores, where that probability is my level of confidence. What I'm saying is the probability, the chance of the population mean being between these two values is 95% or 0.95. And what I'm doing is I'm using these z values, the z-scores, then connect back to an actual value in our real data. And that's what we're doing in setting this confidence interval. Using the sample mean in the middle, my error interrelated to the z values based on the level of confidence that I want. So before we go deeper into our confidence intervals, let's just see if we can identify what are called the critical values. Now, the critical values are asking you for the z-scores such that the area between them is my level of confidence. So I'm looking for z-scores so that the area between them is 80%, or in this case, 0.8. Now, just like we did in the last lesson, the first thing I want you to do is sketch the curve. I want two z-scores, a z1 and a z2, so that my area between is 0.8, 80%. Now, as we did in our last lesson, our calculator only knows area left. So if my area between, if this confidence level is 0.8, then I find that area outside. They actually use that as the letter A or alpha in the Greek letter, as 1 minus that, 0.2. And that's what I want as the area outside my two values. Of course, we know that we need it on only half. So I take that alpha, that A, that area outside, and I cut it in half. 0.2 cut in half is 0.1. And I use that as area left of my first z-score. As we move forward, you will hear that as area in one tail of my bell shape, of my normal distribution. From there, I'm going to bring that calculator up. We're going to go to our inverse norm. 0.1 is my area left. And it gives me my first z to be negative 1.28 with rounding. But thanks to symmetry, if the first z is negative 1.28, then the other z is 1.28. And so these are what we call our critical values. And those are always connected back to my level of confidence, to the probability of what I want between them. Now, these z-scores are not going to change. If you want 80% confidence, if you want 0.8 between them, those are my two z-scores. And rather than having to go through this process each time, in part of our formula sheet, I have already built, well, let me move over. There we go. I have already built in a list for you. So C is our level of confidence. So this would be like 80%, 85%, 90, 95, 98, so on and so on. These are very common levels of confidence. Where you see alpha or A, this is the area outside of my two z-scores. And then we cut that in half. So when you see z of alpha over 2, this is the z-score that is related to one tail, aka the critical values that go with that level of confidence. So it's all relating back to what we've been doing with that area, that probability. And in this case, how confident I want to be in my data, in my confidence interval. So coming back over here to our lesson, our critical values would be the positive, negative 1.28. And all that is are the two z values that gives me 0.80, 80% probability in between them. Area between. Now, as we move forward, these z-scores are what are going to help us build that confidence interval, because we know that there are actual x values that go with them. So everything we're doing is interrelated and connected back to that normal distribution. So if I'm looking for the margin of error so that I can create my confidence interval, I need to have that simple random sample, right? I have to be able to have a sample mean as my point estimate. I'm going to need the standard deviation. I need to know the population standard deviation. We need that sample size to be big enough or to be normally distributed so that we can follow our simple central limit theorem. And then I have a formula for my error. To calculate the error, that is my critical value, the positive version, that z-score, times my population standard deviation over divided by the square root of my sample size. We're going to hand calculate this one time, and then I'm going to show you how to do it in the calculator. So example 4, researchers want to estimate the mean monthly electricity bill in an large urban area using a simple random sample of 100 households. So this is kind of similar situation to what we had earlier. However, rather than giving me that confidence interval, all they tell me is that the population standard deviation is known to be 1550. It's important that you know that because I said population, this is sigma. They want me to find the margin of error. So my error is the question mark with 99% confidence. So my C is 0.99. Now in the last slide, we were given a formula for error. error is found as my z-score alpha over 2 times sigma over the square root of n. Remember that this is just the z-score that goes with my confidence being 0.99. So that's where I'm going to bring up my formula sheet. If you want to hand calculate these critical values, you can, because we just did one and we did it literally all of our last lesson. But because 99 is part of my regular chart, I can go straight over here to my z-score. The z-score that goes with that level of confidence, that critical value that goes with my level of confidence, is 2.575. So I'm going to use z to be 2.575 based off of that critical value chart. So my margin of error would be that z-score times, on top is my sigma. My population standard deviation is 1550 over the square root of n. Remember that n goes with my sample size. And in my calculator, that would be 2.575, open my parentheses, 1550 divided by the square root of 100. Move outside, close your parentheses. My error, 3.99. What this would let me do then is, if I knew my sample mean, I could add my 399 to find the top side of this value. I could subtract my 399 to find the bottom side of this value. What we just did is found, I don't know my point estimate here, but I do know how far I should move left or right of it in order to find my confidence interval. To find that confidence interval, if you know your error, you add or subtract it. And we say that we have a certain level of confidence that our population is between those two values. Now, really, this is something you're going to see done in the calculator. Okay, but we know how to calculate the error now. We can plus or minus it. In the calculator, we can do this using the z-interval. So we're going to go back to stats like we did in some of our first unit. And this time, rather than going to calc, we're going to move over to tests. And you're going to scroll down to where it says z-interval. Z, because this is based off of the z-score. And I can do this anytime I know that standard deviation from the population. Just like we did up here. I knew the population standard deviation. I had a z-score. That's when I'm going to find the z-interval. Once you have the z-interval, it will give you two options. If all you have is raw data, that's when you would use this one. But most of the time, you'll know the statistics. You'll know your sigma, your point estimate, that's sample mean, and your sample size, your confidence level, and calculate. Example 5. In order to estimate the number of calls to expect at a new suicide hotline, volunteers contact a random sample of 35 similar hotlines across the nation and find that the sample mean is 42 calls per month. Construct a 95% confidence interval for the mean number of calls per month. Assume that the population standard deviation is known to be 6.5 calls per month. Whew, there's a lot in there. I'm looking at a random sample of 35 hotlines. That tells me that N, my sample size, is 35. Because my N is bigger than 30, I can follow that normal distribution. It tells me a sample mean of 42 calls. Sample mean is my X bar. Make sure you know the difference. Sample mean is X bar, 42 calls per month. They want me to construct a 95% confidence interval. So that tells me C is 0.95. Now, in our last example, I had to connect that back to my z-scores, my critical values. But in this case, my calculator is going to be able to do all of that for me. And the last thing I need to be able to tell it is that I know the population standard deviation to be 6.5 calls. That is sigma. Because I said population, sigma is 6.5. Sigma, because I know population standard deviation, they want a confidence interval. That's when I'm going to go to second. I'm being silly. We don't hit the second button. Had to look at it. I'm going to go to stats. Now I'm over to test because I'm testing things. And we want a Z interval. So stats, over to test, down to a Z interval. I know my actual statistics. I know that my sigma is 6.5. I know that my X bar is 42. I know that I have 35 random samples, and I want a 95% confidence level. Right there up at the top, that is where they are giving you your confidence. So on the left, I have 39.845. On the left, 44.153. So what they're doing, they used 42 in the middle. They calculated and added or subtracted an error, giving me 44.2 if I round on the right side and 39.8 on the right side of that interval. So somewhere in between these two values, my actual population mean should live. So I would say that with 95% confidence, the true average number of calls per month is between 39.8 and 44.2. Whew. Y'all, this lesson is getting long. So tell you what, why don't we stop here? Actually, no, what I would like you to do is use that to try number 6. Number 6 is set up the same way. I want you to try number 6. When we come back in the next video, we'll make sure you got 6 correctly. Then I need to show you one more type of distribution for my confidence intervals, and we'll wrap up the lesson.